short video because we just have to go through the 4 type problems for this N1 standard. Okay, so for standard N1, it basically takes what we've been doing with normal distribution, takes it one step further to even more simplify the numbers. And if you work with statistics at all in your job, or probability of certain events happening, you will see a standard probability or standard normal distribution used, which basically just means they're taking the normal distribution curve that we've been working with that has a mean and standard deviation, and they're making the numbers a little bit nicer to work with. So a normal distribution has a mean of 0 and a standard deviation of 1. To find what we call the z-score, or you have this group of data where the mean is not 0, in order to make it fit this scenario, they come up with z-values by taking the x that you want, subtracting the mean, and dividing by the standard deviation. So a z-value, or z-score, is a z-value for a particular x value. A z-value just represents what quadrant they're in now that we've converted to this scenario where I have a mean of 0 and standard deviation of 1. So z-score, a z-value for a particular x value, it is the number of standard deviations from the mean. So instead of saying the standard deviation is 14, let's say, we would say, okay, if the z-score, the z-value is 2, that means the x that you're looking for is 2 standard deviations from the mean. It's just basically answering the same question, just a different way or a different look at it, because it's looking more at standard deviations instead of like numbers like how we had yesterday. Alright, using a z-score table, you're going to, or a z-score table, let me show you an example of what it looks like. A z-score table looks something like this, where you have points up here and z's that come down here, and we're going to read through how to use it. But basically use it to find the probability that z is less than or equal to some given value. So if z is randomly selected from a standard normal distribution, what's the probability that z is going to be less than or equal to some value? Alright, let's look at an example. Again, this standard normal distribution, it's not hard at all. It's just knowing how to read the table and then what they're actually asking you for when they see a z-score. For example 3, scientists conducted aerial surveys of a seal sanctuary and recorded the number x of seals they observed during each survey. The number of seals observed were normally distributed with a mean of 73 and a standard deviation of 14.1. Find the probability that at most 50 seals were observed during a survey. So, in this case, they don't tell me to use a standard normal distribution, but we're going to use a standard normal distribution to answer this question, so I don't have to make the whole curve and all the standard deviations and then figure it out from there. So in a way, this is kind of a shortcut because we only have to figure out one fraction here and then use a table to find the value. Whoops. Okay. So we're going to find the z-score for this situation. 50 is the x, because remember I said the x is the number that you're trying to find the probability for. So 50, at most 50, minus 73, which is the mean, all divided by a standard deviation of 14.1. So we get 50 minus 73 divided by 14.1, and you get a z-score of negative 1.6-ish. Okay. So if that's my z-score, what that's telling me is that I'm almost 2 whole standard deviations from the mean to the left of the mean. Okay, so we're going to use the table to find the probability of at most. So the probability of at most 50 seals is, okay, then if we look at our table, negative 1.6 You go to where z is -1, follow it all the way over to where you have the 0.6, so -1.6. You get the value 0.0548, and that's your answer. Or you could say 5.48%. Either way. Okay, so again, to reinforce, a z-score finds the same thing that you were doing with drawing a bell curve, drawing in your mean, and drawing all your numbers for your standard deviation. It does the same thing, it's just kind of a shortcut, because you're converting it to this z-chart, which are always the same values down here, and then finding the probability that way. So z is the number you're looking for, minus the average all over, standard deviation. And then that number, you use the table to find the value. Okay. Obviously, we're going to practice this a little bit more on Monday. Make sure you come ready to work and learn so that you don't get behind. This is Chris Cross signing off.